Alright, hello guys. So here I want to explain about the CLO3 and CLO4 assignment. My name is Faizal Musharraf and my ID is 1013-1244-0040. So let's get to the number one. So uh, here is the question. Due to a storm, air traffic control instructs a pilot flying at altitude of 4 miles to make a 90-degree horizontal turn while climbing to 4.2 miles. The path of the plane during the maneuver is modeled by. So here we have the RT 10 cos 10 p t 10 sin 10 pt, comma 4 plus 0.2 t, and 0 is less than equal than t, less than equal than 1 over 20. So find the speed of the plane during the maneuver and then compute the tangential and normal components of acceleration AR and AN, which one is 0 and y. So first we want to compute the part A. First is v t. So we will find the magnitude of Vt, which is square root of minus 100 p sin 10 pt square plus here 10 sin pt square 100 p cos 10 pt square root plus 0.2 square. So what is the result? So here is the result. So the result will be square root of 100 p square sin square a square sin the power of 2 10 pt plus cos 2 cos square 10 pt, and then plus 0.04. Here you can see, and then using the identity sin square this is sin square plus cos square is equal to 1. So square root of 100 p square plus 0.04 is equal to square root 986 9869, sorry, 96.04 plus 0.04. So after we compute this, we get approximately like 340.60 mile per hour. And then next we want to compute the B section, which is the tangential and normal component of the acceleration. So here we have AR is equal to V dot A over the magnitude of V, which is minus 100 p sin theta mean 1000 p square cos theta plus 100 p cos theta. So minus 1000 p square sin theta plus 0.2 times 0 over 340.16, which is the what is this? The speed. And don't forget it's equal to 0. Here, equal to 0. So first we will compute a normal component of A n. So the A is equal to square root of min 1000 p square cos theta square plus minus 1000 p square sin theta square is equal to 1000 p square, which is approximately is like 9 8696.0.4, I mean, sorry, 0.04 miles per hour square. Then using the AL, which is square root of magnitude A square minus A square T, which we get the AL is equal to square root 1000 P square minus 0, and we get approximately at 98696.04, like I say in here. So that's all for the number 1. So next we will the compute of the number 2 of CLO3. So first we have this y 1 over 3 x3, the curve of y. Yes, so where both x and y are measured in miles, the maximum safe speed on a curved path is inversely proportional to the square root of the curvature, blah blah blah. So we will compute A. If a car safely travel at 330 miles per hour at the point 1, 1 over 3, how fast can it safely travel at the point 3 over 2, 9 over 8? So we will compute first, find the curvature formula for y is equal to fx, which is the kx is equal to fx and x over 1 plus fx and x square, the power of 3 per 2. And then we compute the derivative of the x squared. Fx and x is equals to x squared. Fx and x is equal to 2x. And then we compute the curvature, and then we get this, and then we compute the curvature at x equals to 1. So k1 is equal to 2 times 1 over 1 plus 1 square power of 3 over 2. So it's equal to 2 over 1 plus 1 power 3 over 2. So it's equal to 2 over 2 power of 3 over 2. So it's equal to 2 over 2 square root 2. So it will equal to 1 over square root of 2. Then k, we compute at x 3 over 2. This is x is equal to 1, and then x equal to 3 over 2. So it will be k 3 over 2 is equal to 2 3 over 2 over 1 plus 3 over 2 square, the power of 3 over 2. So it will equal to 3, 1 plus 9 over 4, the power of 3 over 2, 3 over 2, sorry. So it will equal to 3 over 13 over 4 to the power of 3 over 2. So it will equal to 3 over 13 over 4 square root of 13 over 4. And then we compute this and we get the 24 over 13 square root of 13. That's it. And then next we compute the v1 over v2 is equal to k2 over k1, square root of k1. So we know v1 is 30 miles per hour, and k1 is 1 square root of 2 over square root of 2, and k2 is 24 13 square root of 13. So we will compute the 13 per v2, because v2 is mysterious, is equal to square root of 24 per 13 square root of 13 over square 1 per 12. So it will equals 2, 13 over v2 is equal to 2 1 over 4 times square 24 over 13 square root 13. So we have v2 is equal to 13 over 2 and the square root 1 over 4 times square root 24 over 13 square root 13. And then after we compute all of this, we get like v2 is equal to 13 over 2, and 1 over 4 is like 1.1892 times 24, this square root 24 over 13. Sorry, the square root is like this. So square root 24 over 13 square root 13 is like 0.7155. So it's equal to 30.0.8508. So V2 like approximately is equal to 35.26 miles per hour. And then interpret the geometric significance of curvature in terms of road safety. So okay, this is A1 now. So this is B. The interpretations. First, higher curvature. So it means a sharper turn. And then require low power. Sorry, I mean lower speed to maintain control and prevent skidding. So it will prevent skidding. And number 2 is lower curvature. So it means pendler turn. So it's a low, higher speed, safely. Like, and then number 3 is inverse relationship. For a given friction coefficient, the centripetal force required to navigate a turn increases with both speeds and curvature. So to maintain safety or prevent sliding, speed must decrease as curvature increases. Like that. So that's all for CLO3. Number 2. So next for the question, number 3, CLO4. So we get to CLO4. So here we have t x comma y 400 exponent minus x squared plus y over 2. X is mass bigger equal to 0 and y bigger equal to 0. First, we will compute the a. So the gradient of the vector. So dt over dx is equal to 400 exponent minus x squared plus y over 2 times 2x over 2 is equal to min 400 x a minus x squared plus y over 2. So we have here, and then dt over dy is equal to 400 a minus x squared plus y over 2. So 8 times minus 1 over 2 is equal to minus 200 exponent minus x squared plus y over 2. And then write the gradient. So we have the gradient of the t is dt dx, comma dt dy. So it will equal to minus 400 x a minus x squared plus y over 2, comma minus 200 exponent minus minus x squared plus y over 2. Here is the gradient. And then we find a unit direction vector at 3, 5. So here is we have the evaluate the gradient t 3, 5. This is the B section. Sorry. It will equal to like minus 400 times 3 exponent minus 9 plus 5 over 2, comma minus 200 e minus 9 plus 5 over 2. So it will equal to minus 1,100 1,200 minus 7, comma minus 200 exponent minus 7. So and then the condition is delta t dot u is equal to 0. So it will be 1200 e minus 7 a minus 200 exponent minus 7 b is equal to 0. So minus 1200 a minus 200 b is equal to 0. 6a plus b is equal to 0. B is equal to minus 6a. Erase. So we choose a simple vector and normalize it. So a is equal to 1 and b is equal to minus 6. So the u is equal to 1 comma minus 6. So the u, gradient of u, is equal to square root 1 square plus minus x square equal to square root of 37. Sorry, it's 37. So the u is equal to 1 over 37, square root of 37, sorry, comma, minus 6 over square root of 37. So here is the answer. Thank you. So hello guys, we're back to number 4, CLO 4. This is the last number, and I will explain it as fast as possible. So here we have C1 is 0.02x squared plus 4x1 plus 500, and C2 x squared, x2 is 0.05x2 squared plus 4x2 plus 275. And here is, we have the total profit in here. So what will we gotta do? First, we expand the profit function. So P x1 comma x2 is equal to 15x1 plus 15x2. So minus 0.02x1 squared plus 4x1 plus 500 minus 0.05x2 squared plus 4x2 plus 275 here. So we will compute this, and it will be 0.02x1 squared plus 11x1 minus 0.05x2 squared plus 11x2 minus 1775. Number 2, step 2. We will find a critical point by taking a partial derivative. So, dou p over dou x1. Great. So is the critical point is equal to 0 minus 0.04x1 plus 11 is equal to 0. And then minus 0.04x1 is equal to minus 11. So it will be the x1 is 11 over 0.04, so it is equal to 275. Here is the critical point. And then the dp over dx2. So it will equals to minus 0.10 x2 plus 11 is equal to 0. So we have minus 0.10 x2 is equal to minus 11. So it will be x2 is equal to 11 over 0.10. Sorry. So it's equal to 110. Here is the critical point. Then we will verify this is a maximum. So d square p over dx1 square is equal to minus 0.04. It is less than 0, right? And then d2p, d square p, over dx2 square is equal to minus 0.10. It is less than 0, right? So d2p, d square p, over dx1 dx2 is equal to 0. So we have d is minus 0.04 times minus 0.10 is minus 0 squared. So it's equal to 0.004 is bigger than 0. Here is the A point. So the B point, I will write it first. So I finished to write the B. So in short, to maximize profits, the company should produce 275 units at location 1, then and 110 units at location 2, because location 1 equal greater production efficiency, so it will lower cost increase rate. So location 1 is better than location 2. That's all. Thank you for listening to my video. Goodbye.